I would invite Deepashri ma'am to start the session. Deepashri ma'am, you can start the session, ma'am. Deepashri ma'am?
Hello, hello. Am I audible?
Yes, ma'am, you are audible.
Okay. So, I gave you a sum for homework in morning class. So, did anyone solve? Anyone tried to solve? No one. Does anyone want to volunteer also? That, ma'am, I have done these and have tried solving the question like this. No one. The question that I gave you in today's morning. Okay, very good. If you are not practicing, you will suffer in your exams because these are the type of questions you can see in your Neet. Anyways, A. If the gas is ideal, I gave you the formula that is into 100. So what will be 1200 is already given, right? Well, it is kilojoule. So 120. So 1200 joules. I have converted joules to joules. And what is the B? The B is integration of du is NCVM T2 minus T1 plus integration of T dP by dt at a constant volume minus P del V. Okay, so if you just solve, this value is given. This value is given as 1200. We just calculated. 1200 plus integration of 0.02 to 0.04. We can write it as nRT. nRT by V minus NV. Why? Because we know this formula. P plus N square by V square is equals to nRT by V minus NV. Okay, so from that formula you can use. Now, once you have learned integration, you can easily solve this formula. So this is the equation for van der Waals. We already know this equation. We have learned in our morning class. Right. So from there, we can just put the values and solve for it. As simple as that. Okay. Next. So now let's start about in case you are revising and you find any doubt, feel free to contact me. Okay, so let's start with first law. First law of thermodynamics. So we have already learned enough about the basics, the numericals, and what are the kinds of the numericals we can expect. So finally, we are entering the first law. This is the law which is based on conservation of energy. Based on what? Conservation. Okay. It is based on the conservation of energy. And I am not writing the definition. So according to this definition, what it is given, energy can neither be created nor be destroyed. It can only be transferred from one body to another. Definition is something you have to read from book. Though in class 11th, no one will ask you the definition, but it is okay to know the first law of thermodynamics. So suppose, now we will read what comes in our exam. So suppose a system has internal energy E, like internal energy, I'm writing that as E. It is U1. Okay. It exchanges some heat with its surroundings. So, okay, and work done is W. Okay, work done is W. So, according to the first law of the thermodynamics, U2, that is the final, it will be U1 plus Q plus W. So, U2 minus U1 will be Q plus W. So, delta U is equal to Q plus W. So, du is equals to dq plus dw. This is the derivation for first law of thermodynamics that can come in your exam for 2 marks. Okay. Now, what is important for our NEET exam? That I'm writing here. Applicable.
Ma'am, what is mean by Q?
What is?
Q, ma'am.
Okay. Now, very good question. What is Q? Were you present in the first class? What is Q? Heat. Heat is Q. Even in the morning also we told about heat, right? It is heat. Okay. In case you have forgotten, just go through the notes, like this notes, and then you can easily get hold of what is Q. And don't forget about this. Okay. So where was I? What was I saying?
Applicable.
Okay, something for NEET. So this is applicable for all kinds of process and for all types of fluids in closed system. Okay, so this is something. So if anywhere you can see a question for this equation, you can be sure to apply it for everything. Okay, there are no restrictions. Okay, so let's move to next thing. So just suppose a question. Okay, let's do a numerical on this part. Pressure of a fluid. Pressure of a fluid is a function of volume. This statement will not be given in your exam. Since you don't know this, I'm writing it. P is equal to A plus BV. And internal energy is given by V is equals to 34 plus 3 PV. Find A, B, W, delta U for a change in state. This is Ames question. The numericals I have forgotten, but these are this is the Ames question. For the state change from suppose 100 Pascal, 3 meter cube to imagine 400 Pascals, 6 meter cube. Okay, so can you solve this? I am there to solve, but just try. This is very simple. You don't have to read the chemistry part to answer this. You don't have to read the chemistry part to answer this question. Very simple. Want to try or I will say? Okay, just try for 1 minute. Then I will say. Okay. So, no one. Okay. So, this problem deals with pressure and internal energy. So, this problem deals with pressure and the internal energy of a fluid. The pressure is given as P and it is said that pressure is the function of volume. And thus, the equation is like this. So, pressure depends on volume in some manner which we don't know. And the internal energy, it is U. And the internal energy, it is given as function of volume again. Okay, so both are given with respect to the functions of the volume. Okay, that is it. So our goal is to find out the constants which are A, B, W is the work done, and this is what? Internal energy change. Okay, so for a system like this. So first, let's calculate the change in volume. Change in volume. What it is being said? 6. It was V1. It is V2. So V2 minus V1 because volume can't be negative. So 6 meter cube minus 3 meter cube. It is 3 meter cube. Okay. So now we will use the given pressure equation to find V. This is step 1. Step 2 is use the given pressure equation to find A and B. So initial state. For initial state, P1 is equal to 100 Pascal and V1 is equals to 3 meter cube. That is 100 is equal to 3A, sorry. A plus 3B using this equation. Okay. Okay. So for final state, for final state P2 is equal to 400 pascals and volume 2 is 6 meter cube. So what I will write here? 400
400 is equal to
A
plus
plus
A
3.
B.
6B.
6B.
Now, I guess you don't read in class 5. I don't have to teach you how to solve this equation. Yes or no? Calculate A and B and tell me. I just gave you random numbers. Just calculate A and B and tell me. Tell me, tell me.
1 minute, ma'am.
A is what?
Minus 200.
Minus 200, ma'am.
Minus 200 Pascal and B is 100, I guess. Yes.
Yes, ma'am. 100.
What? Your A and B. You got your A and B. Now we will be calculating work done. So work done, what is the formula? Integration of A plus BV dV from V1 to V2. So what I will write? Minus of 200 V plus 50 V square from 3 meter cube to 6 meter cube. So that will come as 700. Now, why I have written the work done like this? No one understood and no one asked me also. Okay. So the integral form of PDV that gives the, I'm writing here. Integral form of PDV gives us the total work done. You will learn this in physics. Okay, so in this case, the pressure, according to the question, what is pressure? Pressure was given as A plus BV.
TV.
Okay, so if you integrate this, you will be getting A plus BV dV. Okay, you will be learning in your maths class. Now, what are the limits of the integration? Next comes the
V1.
of integration. What is our variable?
V, ma'am.
Yeah. So V1 is 3, I guess. V2 is 6
6.
meter cube. Good. Then, so the integral value is evaluated using the power rule of the integration. Okay. So I'm just writing that I have done it verbally, but don't do this verbally. You can know that integral value is being calculated using power rule. Rule of integration. Okay, so and then we have substituted the limit. Substituted the limits. So what we got? This is something you will be getting after the integration. Okay. So just we put, now here we put the values of V1 and V2. And then I will get, now next is, okay, this is step number 1, step number 2, step number 3. This is step number 4. So then plugging. Plugging in the values of V1 and V2 in equation C. We get W is equals to minus 700 joules. Okay, so this is the basic form. I don't think this part came, work done came. This work done I saw in a very old IIT paper. I don't think work done came for the JEE. But this is the basic thing, okay? Is this part clear to everyone? Yes or no?
Ma'am, can you explain C?
See, C is something you have to like 3, 6 and you have to do this integration, okay? So after doing the integration, you will be getting a value like this. This is something like after doing the integration part. This is after integration. After integration. Okay, so you will be getting an expression like this. From here, I have just added the V1 and V2 values and then I have got this answer. Okay.
Ma'am,
Minus 200 plus
750.
50. Then how it will become
I
700?
can't understand. I can't understand. Yeah, say.
Minus 200 plus 50, how it will be 700? Ma'am,
That is
minus
something you will be getting after the integration.
Ma'am, I got 750 joules.
That is too much. You have made the corrections wrong. Okay, this is something, I don't know why people don't teach integration in the younger classes, but this is one of the major drawbacks for integration. Okay. So I can just show you, I don't know how much you will be understanding. I have used the power rule integration. Power rule of integration. So this rule states that integration of x to the power n will be equal to x to the power n plus 1.
And by n plus 1.
Yeah, by n plus 1. Okay, so n is any real number. Any real number except minus 1. So this is something I know. This is something you will be learning in details in your maths class. Now, what was our equation? This a plus bv dv. Now, if you apply here the integration rule, that will come as av plus b square.
Bv square by 2.
Not b by 2. Sorry. Yeah. Good. bv square by 2 plus constant. We always write this constant. This is the general equation, okay? So, however, since we are calculating the definite integral from V1 to V2, this C will be cancelled out. So, here we will not write the C. But in your maths class, you will be definitely writing, because or else your teacher will scold me that you have taught integration without doing this. Now, in this step, so is up to this it is clear? Now I have just put the values of A. A is my, wait,
minus 200.
yes, minus 200 V plus, what was B?
100 v square by
So
2.
that is 50. 50 V square. Is this part clear now?
Yes, ma'am.
Good. So now, how we are substituting the value? Someone got 7,000. Okay, let me see. I also calculated verbally. Is minus 200 V plus 50 V square, right? This was our equation from
Yes.
3 meter cube to 6 meter cube. Okay, so minus 200 into 6 plus 50 into 6 square. Whole thing minus of minus 200 into 3 plus 50 into 3 square. So it is minus 1200 plus 1800 minus of what? Minus 600
600,
plus 450.
450.
Yeah. So this will be 600 minus 150. Okay, so I calculated this minus wrong. So this will be 450 is the answer. 450 joules.
750, ma'am.
Yeah, not 750, it
Minus
will be 450. Okay, is this part clear?
would be
Minus into minus plus, it will come
Oh
750.
yeah,
plus
750. 750. So is this
750.
part clear?
Yes.
The entire calculation. How after integration we
Yes.
are getting that and so on. Good, very good. Now the last question was what? Calculation of delta U. So last question was calculation of delta U. That is what? U2 minus U1. Simple. This U, that function was given as P1, V1, 3P1, V1 given, right? Minus 34 plus 3P1, V1. Sorry, this will be P2, V2. Now just substitute the values. 3 into P2 minus, P2, V2 minus P1, V1. So that will be 3 into a huge bracket. It is 400 pascals, 6 meter cube minus 100 pascals. Now you just solve this. Whatever you will be getting, that will be coming in 750 joules. Okay, so this will be the final answer. So is the entire numerical clear to every one of you in the class? Is this part clear to everyone? Speak out. This is the formula that was already given to you in your question. This is not something rocket science. This was given in your question.
6,300, ma'am.
Whatever. This doesn't matter. But did you understand the concept?
Yes, ma'am.
Okay.
Yes, ma'am.
So till now, we have done quite a few numericals. I guess this will be coming in your exams also. So now, okay, next part. I expect this. If you are reading, following every day's class, you are supposed to get good marks in chemistry at least. Enthalpy, chemistry and bio. Enthalpy. So it is represented as H. And what is this? It is mathematically defined as H is equals to U plus P del V. Okay, again, I have made the mistake. This is not U. This is V. U plus PV, or simply you can also write that U PV also. This term you can write as PV also. PV as a U also you can write. So it is an intensive property, obviously. It is an intensive property. And also it is a state function. Very much common. So absolute value of H can't be determined. Absolute value of H can never be determined. These are the basic properties for enthalpies. Okay. Now, H is equal to U plus P del V. Okay. So, if we H plus del H, that will be U plus du. This is differentiating. I am differentiating. You don't know about differentiation also. Plus P plus del P with V plus del V. Just for the sake, you just trust me that whatever ma'am is saying, it is correct. It is after differentiation. And we can write it as del H. Del H is dq plus dw, where PV is constant, plus dw non-PV. I told you there are two types of what? Plus P del V plus V dP. Okay. So del H comes as dq plus dw non-PV plus VD. Okay, so from here I am writing it here. So in constant pressure, after this, in constant pressure, delta H is equal to delta Q at constant pressure along with delta P, which is non-PV. So these are just the derivations which will come in your board. This will never come in your exam. Okay. I will tell you the conclusions. Now, if dW non-PV is equals to 0, then delta H becomes dQP. Okay. Or what I can say, delta H is equal to QP. This is a very important formula. I will be using in quite a sense. This is a very important formula. So to derive this, we have to start from here. For your Neet, remember this derivation and everything will be coming for your boards. Derivation for boards. Okay. So, what note we got from here? What we have to remember? Delta H is equal to delta U plus P2V2 minus P1V1. This is the main thing we have to remember. Okay. Now I will be telling you a list of process and where to apply what. Okay. So these are the basic things we will be learning for every category. So let's now just do calculation of delta H. Calculation of delta H. Where to use what kind of formulas? For physical process. For physical process. H is equal to U plus PV. This is something we know. Delta H is equal to delta U plus P delta V. Pressure remains constant. Or you can also write like this. Delta PV. You can ask me, ma'am, doesn't the pressure changes? Yes, the pressure can change. So delta PV. So for ideal gas, this is the basic formula which you will be using in maximum cases. For ideal gas,
PV is equals to nRT.
yeah, very good, very good. Is equal to U plus PV. But instead of PV, we will be writing it as nRT. Then, so H here becomes a function of T. This can be an important conclusion, okay? So in your Neet, they can ask you that is H a function of temperature for ideal gas? And they can give you 4 options, A, B, C, D. So you have to correct this option. H is equals to Ft. So this is the correct answer. Okay, so this is a very important conclusion. So for real gas and the other substances, this thing remains same. For real gas and other substances, how do we formulate? Ht is equals to function of PVT. So all the 3 terms vanish. So H is equal to function of PV. It is also equivalent to function of VT. It is also equivalent to function of PT. So this is something we have already learned before. So let's do it in the next page. This is an important thing for your boards. For ideal gas. This is very much important for your boards. So what is this thing? Delta H by delta P at a constant temperature is considered to be 0. Delta H by delta V at a constant temperature is 0. This is something we take as standard. Okay. And delta H by delta T. What is this? At a constant pressure, it is NCPM. Okay, which we can also write it as CP. These are the things we already know. So if they ask you why H is a state function, you can show these derivations and say therefore H is a state function. This question has frequently come in your boards. So write like this. Okay. Now, dH, differentiation. dH by dP at a constant volume into dP plus dH at dV at a constant pressure into dV. This is marked as equation 1. Again, dH by dV. It is constant T at a constant T with a constant volume. Whatever we are writing here, we are writing here. Okay. Whatever we are writing here, we will be writing here. Pressure, volume, volume, pressure. Like this, we will be alternating all the 3 terms. By dH, dt. Constant volume, dt. This is the second equation. And the third equation, dH by dP at a constant temperature into dP plus dH by dt at a constant pressure into dt. These are the three different equations, okay, that we can get from here. We have told you that H is a function of pressure, volume. H is like this here. See, if we say H is a function of PV, H is a function of VT, H is a function, this is function, not integration, PT, then by the mathematical law, we can write this as this. Okay, if we know this, like since we know H is a function of PV, is a function of VT, is a function of what is left, PT, then we can write like this in mathematical terms. Okay, by differentiation, by pure differentiation, we can write like this. Is this part clear? Now, how you can write like this? That is a long step formula, and there are many other different things present to explain. Like that will take an entire differentiation class, and I am not supposed to take differentiation. I am not your maths teacher. So when your maths teacher will teach you, then you can see that if something is given as a function of this, then you can write like this. So out of this given equation, which equation we uses more? This. Out of all the given equation, this is maximum used. Maximum used for your numericals. Okay, maximum used, and this is the thing. Okay, now let's start. Okay, case 1. So what is the case 1? Ideal gas undergoing any process. Okay, so there DH So this will be the formula that will be used. If I just generalize it, this is something for your IIT. In your IIT, they give equations like this, and this is something for your Neet. I'm not going how this comes like this. Just for your sake, understand that for your ideal gas in your question, if these words are written, in your question, if these words are written, use this formula to calculate. Okay. Okay. For your IIT paper, the JEE mains paper, they can ask you a question and they can ask you this formula. Which of these formulas are correct? Or they can give you the values T1, T2, CPM, N. Everything will be given. You have to calculate this delta H. So is this part clear? How the question will come? Clear or not? Okay, so case 2. Case 2 is for real gas, no. It is for the real gas undergoing isobaric process. Real gas undergoing isobaric isobaric process, right? No, okay, isobaric process first. Isobaric process. So here, what formula you will use? Basically, for real gas and for the ideal gas, this formula remains same. Only this part doesn't get cancelled out. Okay, only that part, only this part will be cancelled out here for ideal gas, but it will play a role in real gas. Is this part clear? And okay, one more I forgot to tell. It is case 3. It will be a real gas undergoing any process. Undergoing any process except isobaric process. Okay, so for that formula will be dH is equals to N CPM dt plus dH by dP T into dP, or delta H will be given as N integration of T1 by T2 CPM dt plus integration of P1 by P2 dH dP at a constant temperature into dP. Okay, so these are the 3 cases. This exactly in your exam, these types of words will be given to you. Okay, exactly these types of the words will be given to you during your exam, during your exam. Ideal gas, undergoing any process, real gas undergoing isobaric process, real gas undergoing any kind of other process, isoporic process. This exact statement will be given. Just try to find these keywords. Once you get these keywords, you can easily understand which formula to use. Either they can give you the choose the correct formula, or if they are asking you to calculate, use this formula. Is this part clear, everyone? Okay. So from definition, one more thing I want to say. From definition, delta H is equal to delta U plus delta PV. Right? This is something we know. For ideal gas, what I told you, that delta H is equal to delta U plus nRT. Okay? And for solids and liquids, very important. For solids and liquids, delta H is equal to delta. Okay? Is this part clear? Where to use what kind of formulas and what are the logics behind using any kind of the formulas? Whatever derivation I am doing, just do those derivations. Okay, so maybe that will be helping you a lot. Okay. Achha. Okay, so there is something more. Okay, we will be starting it in the next class, and then we will be doing with the calorimetry. Okay, so after that calorimetry, we will be doing many sums, reversible, irreversible, how to calculate and everything. Okay, we will be doing many sums. Like I will be doing only the higher level of the sums. The rest sums will be practiced by you. Okay. So the rest of the sums will needed to be practiced by you. In case you are doing any sums from your book and you can't solve, please feel free to ask me in the next class. Because in the next class, when when you come and ask me the question, then others can also get to know what is the doubt or how to deal with that doubt. Okay, so is this part clear to everyone, whatever we have taught so far? Any doubts, anything?
Ma'am, I have a doubt between, I have doubts in derivation only, ma'am.
I can't hear you.
I have doubts in only derivation, ma'am.
Yeah, for that derivations part, that is how I am writing like this and that, right? So just for the sake of understanding, these are the different formulas. Okay, these are just the formulas. But I have told you, if something is written as a function of this, they can be written like this after derivation. Now, how they can be written, that can be taught to you in your maths class. Okay, so these are the different formulas. Okay, so these are the things. Once you learn the definitions, it will be easy for you. Okay, apart from this, any other kind of doubt? Hopefully, no, just practice the sums, okay? Once you are done, just try to practice the sums. If you can't solve any question, then ask me in the next class, like in tomorrow's morning class. In the evening, sir will be taking your organic tomorrow. And in the morning, I will be taking your class. Okay? Is this part clear? Is this part clear?
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, wait. Yeah. So, ma'am, are you there?
Yes, ma'am.
This was from my end.
Okay, okay, ma'am. Let us take a test. You are done with the class, ma'am? 30 seconds time was given. Yes, ma'am?
Ma'am, I'm done.
Okay. Okay, students, again we have class tomorrow morning from 5 to 7. Right? So, bye everyone. We will meet tomorrow morning from 5 to 7.